we are expected to calculate the tension in the two cords. So from this very diagram, the cord, let's say this should be our T1 and this should be T2, okay? This should be T2, all right? So we are looking for T1 and T2. T1 is the cord from this side and T2 is a cord from this very particular side, okay? So if here is 50 degree, it simply means that this angle is going to be 50 degree alternate angle, and similarly this will also be 30 degree alternate angle. You know, these are two similar triangle. ABC is equal to triangle AEC. Okay, so if that is true, it simply means that this very particular angle can also be 30 degree, while this can be also be 50 degree. So we are picking out triangle ABC. You can pick any of them, of course. Then again, there is something very important I would like to share with you here again. If from line AE is T1, then it simply means that line BC will also be T1 because this is a parallelogram. So line EC will also be what? T2. So considering triangle ABC, we're just going to have something like this. Something like this. Something like this, okay? So this is 50 degree, this is 30 degree, which is this one, and this should be our B, and this is A, and this is C, and of course this line here is 20 Newton, which is the first, so here will be 20 Newton, okay? So if that is true, what we need here is that we have angle A, we have angle B, we don't have angle, we have angle C, we don't have angle B, okay? And to get angle B, just subtract 50 plus 30, you subtract it from 180 because sum of the angles in the triangle is equal to 180 degree. What I mean here is we have just 180 minus 50 plus 30 will going to give us 80. Then it simply means that our answer will going to be 100 degree. That means this very particular angle is 100 degree. We obtain it as a result of summing the whole of the triangle and equating it to 180 in order to look for the B. You're going to get 100 degree. So now that we have obtained this, our own aim is to look for T1 and T2. But where is T1? This is T1, that is the line between CB. So we have our T1 and this should be our T2. So let's calculate T1. To get T1, we must use what we call signed rule. So using signed rule, we're going to have this. If you are picking the T1, you relate it with this very angle. So let's do it this way. We say this A should be equal to the side that capital A is fastened. Let's give it small a and it's equal to T1. The side that capital B is fastened, let's give it small b and it's equal to 20. The side that C is fastened, let's give it a small c and it's equal to T2. So we're using picking A, we have small a over sine capital A equal to B over sine capital B equals C over sine capital C. Okay, so that is what we're going to be using. So if you decide to pick A, our A, small a is T1, so we have our T1 all over sine 50 equal to our B is 100, our B, small b is 20 all over sine 100, okay, sine 100. So our T will be T1 will be equal to this will multiply this, so we have 20 times sine 50 all over sine 100. So if you evaluate it using your calculator, it will give us 15.55. Okay, so 15.55 is our T1. All right, so if this is our T1, then we have to look for T2. All right, T2 now, we relate this with this, or this with this. Okay, so let's see. Our B is what? Our B is 20, so we can say that 20 all over sine 100 equaled C is what? Our C, oh gosh, okay, our C is equaled T2, so we have T2 as a line over sine, then capital C is 30. Okay, so this will multiply this, so we have our T2 will equal to 20 sine 30 degree all over sine 100. So if you have your calculator there, evaluate it, it will going to give us a 10.15 Newton.